Okay, in problem 2, we have some honey that is being poured into a dish with vertical walls and an area on the bottom of 18.3 plus or minus 0.4 square centimeters. So we're going to go with an area. No, brushes, damn it. All right. Pardon my French. An area is 18.3 plus or minus 0.4 square centimeters, and when the honey settles flat out in the dish, the honey has a thickness of 2.2 plus or minus 0.1 square centimeters. So what it is, very simply, is a little dish like that, and it's like that. And this is a horrible drawing, of course. There's the inside, and so the honey settles down into a layer, about that thick. So what this is giving us is the area of the bottom of the dish or the top of the dish or whatever. The dish has vertical walls, and then the height there is the thickness, which I'm going to say, actually, let's not call it T, let's call it H. It's going to be the height of the honey, so that's going to be 0.2 plus or minus 0.1 centimeters. Okay, so total volume of the honey. So what we do there is volume is going to be the area of the base times the height, as it is with any, right prism, I guess is what this is called. So we expand this by substituting for each of these terms. You substitute, so let me make it clear in case you haven't seen this notation before. V here is the true value for the volume, A is the true area, and H is the true area. And we're saying that V is really equal to the value we're about to predict plus some amount of error in V. And the little squiggle on top I used to represent the measured value, okay, and this little curly E means error. So this is the predicted value of volume plus the error in volume, and that's going to equal, and it's the product of the actual area plus or minus error in A times H squiggle plus or minus the error in H. Okay, and then very simply we just multiply this out with FOIL. V squiggle plus error in volume is A squiggle H squiggle. And then let's see, what do we have? Actually, this shouldn't be plus or minus. These shouldn't be plus or minus. Formally speaking, it doesn't really matter. You can do either way, but what I'm saying here is that epsilon, or sorry, not epsilon, but the error in A includes the plus and minus. So I'll show you how it works in a minute. So A squiggle H squiggle, and then you add in yeah, I didn't want that color, but I'm stuck with it now. Okay, so A squiggle H squiggle plus outer, which is A squiggle error in H, plus inner, which is H squiggle error in A, plus the last terms, which is error in A times error in H. And as we discussed in class, this term is going to be very, very small. You can in fact plug in numbers for all these because you know these all. A squiggle is 18.3, error in A is 0.4, etc. And when you plug in the numbers for all these, you will realize that this last term is tiny compared to the others, so you get rid of it. So what we get now, I'll switch to green, is just these three things here. And what you'll get is your predicted volume is, of course, equal to your measured area times your measured height. And then you take this equation here and subtract it out of this. So what's left is the error in volume is equal to A squiggle times the error in height plus H squiggle times the error in area. Okay, so if I plug these numbers in, what I get here is, let's see if ye old calculator feels like working. Ye old crappy ass Windows 7 calculator. I mean, terrible, bad Windows 7 calculator, not any other words. Okay, so 18.3 times 2.2, clear 18. Jesus. I mean, I'm so sorry. I apologize for that. 18.3 times 2.2 equals 40.26. So V squiggle is going to equal 40.26, and for the other one, that is going to be, let's see, A squiggle, so 18.3 times 0.1 equals 1.83. Okay, so 1 1.83 plus, so this is going to be plus or minus 1.83 is this term here, and then plus or minus h squiggle error in A, so 2.2 times 0.4, 0.88. So what we get now is add these up, and you're going to get volume is, let's see, 40.26 plus or minus, and so the 1.83. So remember, this is just like adding up any pair of plus or minuses. You just add everything to get the whole range. So 2.71. Nice. So I suppose, what do we have for sig figs? Well, technically, I've only got 2 sig figs here, so really I ought to truncate it down to 2, I think. I don't know. But I think we're okay to say, I don't know. Mr. Forbes and I have a little disagreement on this, and I'm honestly not sure who's right. So I don't want to be careful with your sig figs if you've got, well, be careful with your sig figs. But I believe the answer then would be, let's go with 40.3 plus or minus 2.7 cubic centimeters. Maybe you should truncate it down to 40 plus or minus 3 cubic centimeters. I don't know. No, I think this is okay. What's really important with uncertainty is that you have the same precision in each one. It looks stupid if you don't, but you don't have to worry too much about sig figs otherwise. Where's my mouse cursor? On to problem 3 as soon as I can stop this thing. There we go.